Hi, my name is Jessica Cahoot, and I'm going to talk to you today about how you can do some quick and easy data collection in your classroom to help your middle school students really understand some science concepts. And so what we're going to focus on today is sweat and having students answer the question, why do we sweat? And for middle school students, I personally have a sixth grader here at home. They can sweat, and when they sweat, they kind of stink. So getting them to think about some ways to answer some questions that relate to them is a great gateway into understanding science. So have them think about, well, why do we sweat? We certainly do, but what happens? Why do we do it? Why do we need to do it? And so our learning progression with this type of activity, we're going to start with getting curious. We want to know what our students already know and what they want to know. And so an entry-level topic like thinking about why we sweat is something that they can all get on board with. And then once we've assessed their prior knowledge and have them kind of think about some of these topics, we then do some data collection. We get them involved in the gathering of data. And then our last part is we need to figure it out. What does this all mean? What did our data tell us? And what can we conclude from it? And what else do we need to know? So the first part we're going to do is we need to get curious. We need to start figuring out what we know and what we need to know. And so we can do this a couple of ways. For our students, we can do something like what's called a driving question board. So we want to know why we sweat. And so from posing that question of why we sweat, we can have the students then come up with their own questions, figure out what they want to know, what happens, get them really thinking about the process of what's going on and how it all works. And so by generating even more questions about our main question of why we sweat, we can kind of understand what they already know and have them start thinking about what they want to know. We can also have them build initial models. So in these initial models, we can kind of get an insight in what they're thinking. By drawing it out, we can start identifying some misconceptions and figuring out where we need to take these students and meet them where they currently are. We could also have them do something like a brain dump where they just write out or draw out what they know about the topic. So we can identify their prior knowledge, misconceptions, and get an idea of where we want to take this. But the main point of this is we want students to really take ownership of their learning and understanding. And from this prior knowledge, we can have them start thinking about ways that they could test this. What kind of investigations would they need to do in order to understand the concept of why we sweat and the underlying science principles behind it? And so what we want to do now is kind of guide them into those investigative questions and investigative studies and do some data collection. And so I've set up an example of a data collection that you could easily do with a temperature sensor in order to calculate what happens when we sweat. Today we're going to be using a TI-Nspire CX2 calculator to collect data on the cooling rate or how fast the temperature changes when we allow water or isopropyl alcohol to evaporate off the tip of a vernier temperature probe. So we're setting up the calculator for a time-based recording of data. So we're recording the temperature, and then we're going to change the rate at which we collect the samples. I'm going to change that to 1 sample per second, and then I'm going to change the amount of time to 10 seconds. So we're only collecting for 10 seconds, but 1 sample per second. And so I'm going to take the temperature probe and place it in the water and let it kind of come to this kind of stabilize. And then I'm going to take the temperature sensor out of the water, and then I'm going to hit the play button, which will then begin the data collection. So as the water evaporates off the tip of the temperature sensor, we're going to be recording what the temperature is. And we have a graph. So what we can do is we can hit that check mark up at the top of the screen, right below the play button, and we can record that data. And then we can do another run with the alcohol. So we can see how the temperature changes with the alcohol and the temperature sensor. And so as we are recording the data, again, this is for 10 seconds, and we're looking at how the temperature changes within those 10 seconds using now the isopropyl alcohol. And it only is 10 seconds, so it's easy to be replicated and redone. So if students make a mistake, it's just 10 seconds. They can repeat it. Now we can compare both of our data points. We have our water in the blue line and our isopropyl alcohol in the red. Now that our students have collected the data, we need to analyze it. And so we're using the TI-Nspire premium teacher software to help us with this. You could still use the handheld, and if you're using a handheld in class, it's a little bit easier, but this will give us a better visual of what we're doing. So in the main screen, we see the actual, what would be appearing on the handheld. And then on the left here, we see what it would look like all together. And we could press the buttons and show our students what's going on and how to access that information. So when we collected the data, we were looking at the temperature change on our temperature sensor. So what was happening as the water and the alcohol evaporated off the tip of the temperature probe. And now we want to analyze that data. So what we're going to do is, well, there's lots of things we could do from here. We could just look at the data and have our students calculate the rate of change based off what they see off the graph. So this is something that they need practice with in algebra class. Depending on what math level they're in, they might need some help with this, but we can also use the calculator to assist that process. So we want to calculate how fast this water or alcohol evaporated off. Well, not necessarily how fast, but what was the change in temperature. So what was the change in temperature and comparing the difference between water and alcohol. So we're going to start by hitting menu. And from menu, we click analyze because we want to analyze our data. And then we're going to go to curve fit. And then we're going to select our temperature. So we're going to start with temperature 1. And based off the data, it fits a linear model. So we're going to click that, linear. And then it's going to give us all of our data and our mx plus b equation. So our equation of the slope of the line. So students can get that information, and as a science teacher, you can help them understand what those components mean. So m being the slope or the rate of change. So for this example, for the water, our rate of change was negative 0.049. So we could round that to negative 0.5. I'm sorry, negative 0.05. So what does that mean? So that's something that you want to talk with your students about. So has a negative slope or negative rate of change, so that's going to be decreasing. So the temperature is going down, and it's going down at a rate of negative 0.05. So it's changing, it's decreasing 0.05 degrees Celsius per second, because that's what we're looking at. Those are the types of things you might need to go over with your students depending on their math background. And then our B is our y-intercept. So that's the temperature which we started. So for the water, we were about 20 degrees Celsius. And so this is the information that they would need to pull out and maybe put in a data table so that they can use that evidence to help support their understanding of what's going on in this process. So I'm going to hit OK, and then I want to analyze our second line, our second piece of data, which is the isopropyl alcohol. So we're going to hit menu, go to analyze, curve fit, and then we're going to go temperature, run to for temperature, again linear, to get that information. And for our linear, we have now our mx plus b, our rate of change, our line of the equation of the line is our m, or our rate of change or slope, is going to be negative 0.12. So there's a big difference between our water and our alcohol. So now we're at a negative 0.1. And our B, our y-intercept is around 20. It's 19.6. So we were very close to our starting temperatures, and we wanted to look at how much it decreased. And so we can use that information to put together a data table and find the difference between them and help our students kind of make some connections between what's going on in the data and what more do we need to understand. And so this is an example of a data table your students could put in their scientific notebook where they're recording the rate of cooling. So they have their two different substances, water and alcohol. They have their initial temperature, their final temperature in degrees Celsius, their time in seconds, and from there, they can calculate their rate of change in degrees Celsius per second. So whether you have your students do this by hand or you use the functionality in the calculator to use the menu-based system to help them visualize it and calculate it for them. Either way, it's up to you. You can decide what's best for your students and what skills you want your students to be building in whichever way. And so by taking this information in the data table, we can start making sense of what's happening here. So we can use our graph, we can interpret our graph, we have our data table, and so we use all this to tell our story of what is happening in our investigation. So what does our data tell us? So we have our rate of change for both water and alcohol. So water is negative 0.05 degrees Celsius per second. Our alcohol is negative 0.1 degrees Celsius per second. And what does that tell us? What is our data telling us? What is our graph telling us? Well, we can see from that information that water has a slower rate of cooling compared to alcohol. And then alcohol, as it evaporates, is going to be cooling 2 times faster than water. And that's pretty interesting. And so we can kind of put that together and kind of gather what this is telling us about these two molecules and kind of bring it back to why we sweat. So at this point, we're working on figuring it out. So thinking about how this all works and what is this information really telling us in the full story. So what did we figure out from this investigation? We figured out that water, as it evaporates, cools the surface. And alcohol, as it evaporates, it cools the surface as well, but 2 times faster. So sweating is going to cool us off. But having this type of investigation primes us for learning, where we want to now figure out why. Why does evaporation cool our skin? And why is alcohol cooling it faster? And what would happen if we sweated alcohol and not water? How would that change? And so there's these questions that come up from these investigations that can lead to more learning. So they're ready for that explanation. They're ready for hearing how this works. So they're going to be taking this information in a lot easier, as well as potentially wanting to do more investigations to figure even more stuff out. So once they're really primed for learning, you can get into those details of why this is happening. How does evaporation work? So if water is evaporating off of our skin, why are we feeling that cooling effect? What's going on a molecular level? What's happening to the energy in these systems? So we can get into the structure of a water molecule, talking about how it's polar and how these molecules interact with one another, whether they're forming hydrogen bonds or that the kinetic energy is changing based on the temperature. And that as the kinetic energy of these molecules get higher, they may leave the system and go through a phase change from a liquid to a gas. And so that process of going through phase changes from a liquid to gas, as the kinetic energy changes and those high energy molecules leave the system, leaving the molecules that are in that liquid state at an average lower kinetic energy that's causing the temperature to be cooler. And so they are now ready. They've seen this happen with just a temperature sensor, some water, and some alcohol, and they're ready to learn. And now we can also compare the difference between alcohol. So, well, why, if this happens with phase changes and kinetic energy, why does alcohol go faster? Why does it cool faster? And so you can get into what happens with alcohol molecules and how the kinetic energy is faster with alcohol molecules. So it leaves the system faster, allowing for the average kinetic energy to be lower in the liquid system. And so they get a little bit more involved. And then, of course, what if we sweat alcohol? We would lose a lot more heat. We would need a lot more energy. And so we probably have to eat a lot more food because that's where our energy comes from. So it's a very interesting concept for kids to understand, a very fun and easy way and a simple way to collect easy data to really help students understand energy and systems, and it's just so much fun. Looking for more ideas, head over to education.ti.com and check out Science-Inspired. You'll find all the content areas, and inside each of these content areas, you'll find links to simulations and more data collection activities to keep your students engaged in learning. And so hopefully this will be helpful for you, and thank you very much for listening. Bye.